So that way, and you'll see, we'll run a little clip, but basically we're calling as many of the fish as we see as possible, because when we're back in Seattle, sometimes people say, you know, that really looks like a, I don't know, an ornate butterfly or whatever, but then we only saw it for a moment, and then it jumped behind a rock. And then if we hear the diver that was on the dive that day say, ornate butterfly, we're okay, yeah. And we got a short glimpse of it. Even if we freeze frame, sometimes it's blurred because they're moving so fast or whatever. So it really helps us with the counting back home. Do we bring any other props?
That's it.
Okay.
Site markers. And
yeah. So you guys understand the methodology here? And in Washington State, where we also do this to count rockfish diversity and abundance, we'll do a straight line, which is 100 meters long, and then come back. Here, we basically run along coral fingers, so we'll set a marker. You've all seen the coral fingers or the reef fingers around here. So we'll set a marker at one end, and we'll go, say, on the north side 50 meters, come back to the center, and then go south side 50 meters. So here in Hawaii, we, except for in Mauna we don't have a straight 100-meter transect. It's more of a bent 100-meter transect. But we just want to be able to count fish in 100 meters. Question?
Can you just talk quickly about what are some of the other important variables that you have to account for? In other words, like time of the year or weather conditions and things like that that would, you know,
skew the data.
Yeah.
Yes. Well, we come here at the same time of year. We're always here at the end of January, beginning of February. As far as the weather and the conditions underwater, we can't control for that. We certainly have records of it. It hasn't affected our data thus far in that, and you'll see a little bit later, everything seems to be staying the same. Certainly some years are better for counting than others. It's easier to see the fish because of the clarity of the water. Some years we have a lot of surge, and we don't know how many fish are hiding because of that. So, you know, it's not perfect, but we're doing our best to be consistent with time of year and our methodology. So, thank you for that question.
Okay. Lastly, the power baseline work is in repetition, and we're looking at large-scale, long-term changes over time. So, an annual difference may or may not, you may not pick it up because of all the items that you mentioned, but over a 10 or a 20-year period, you'll see the significant changes on a big scale.
So here's a little video clip of our research. You're only hearing it off of the computer here, so you can't hear, but I'm telling the camera what site we're at, how deep we are, how much air the divers have, what date it is, what direction we're going. And then this is what it looks like. We follow a vertical reef. And I don't know if you can hear it, but the diver's calling the fish.
Yeah, you're pretty much continually talking as you're making that dive. It's kind of like doing play-by-play for a baseball game or something like that. I mean, you never stop talking because you're looking up ahead and you're like, okay, there's 2 yellow tanks to the left, and I see 3 koa tanks to the right, and up above that there's a sailfin tank, and then there's 2 bullethead parrots that are swimming down the top of the reef, and you're just trying to speak as quickly as you can to talk about all the fish that are in front of you, so that when we come back to Seattle, and then this is the fun part. The hard part is when you're in Seattle and spending the hours watching the video and trying to count all the fish, so that you have that record. It makes it a lot easier to count, what Shawn was saying.
So we always pick a vertical reef structure to follow, or some significant markers underwater to follow, so that we have the same transect line all the time.
Shawn, what camera do you count off? The diver on the side of the transit line?
So yeah, the videographer diver is right here.
Yeah.
Is the closest to the reef.
So he's the video you count back in
Yes.
Seattle.
Yeah, that's correct. This is just
Showing us how it
a
was.
point of view, and we put together a small thing so you can see it from
See the
the
divers actually.
external perspective. So when you're only seeing reef or only seeing tape, that's the actual research camera. And because the 2 teams alternate, when the first team is done with the transect and the second team is starting, we'll hang out for a couple minutes and get that second camera view before we leave and go to the surface.
It's important for documentation when we get back home. A lot of times we host Hawaii weekend every couple weekends in January, and it's isn't it co-sponsored by Hawaii Tourism? And so we're trying to generate, and Waikiki Aquarium, so we're trying to generate interest for people to come to Hawaii, and a lot of people want to from Seattle, especially in January. And they'll show clips of our research, so we'll talk about our research, we'll talk about Hawaii, we'll talk about coral conservation and all the things that we're trying to do, as well as our partners in the other aquariums. So it's important to document that footage.
What depth are you at?
We're generally 25 to 35 feet, sometimes shallower. So we go to drop off for fun. Okay. So here's a little bit of data, and I know this just looks like a bunch of bars to you, but what I'm trying to illustrate is that there haven't been many changes over time since we started this. In Puako, we counted in 2009 46 species. The most abundant species is to the left, the least abundant is to the right. And these are average numbers over the 4 transects that we do. We try and always get 4 transects of each site. So we'll swim each site 4 times, which is 800 meters of tape information. So at any rate, what this is showing you is over time, 2010 we counted 58 species in Puako, 2011 50, in 2012, 54, so it's pretty much stayed the same. There's been little variations in the numbers. You know, sometimes we'll have a school of fish swim through that we count that we don't see the following years, but overall there's just so much data that it doesn't make a significant difference. So then if you look at Old Kona, which is also a semi-protected site, 36 species, less species but more fish because there's these large schools of blackfin chromas. You can see here, this one that was off the chart, almost 500 was the average number of chromas that we would see in those transects, followed by white bar surgeonfish and yellow tang. So 2009 in Old Kona, 2010 saw even more chromas, almost 930 chromas on average per transect. 51 species, and then 2011, 46 species, again a lot of chromas, and 2012, 41 species. So what this is just illustrating is we're seeing a lot of fish, we're seeing a lot of diversity of fish, but we're not seeing changes over time yet. And I'll show you another slide that makes it even easier to see that. And then we didn't count Makai in 2009, so we just have data for Makai in 2010, 11, and 12. So here's Makai, 36 species, far fewer than Puako and Old Kona. 2011, 39 species, and 2012, 43 species. So diversity is the average number of species of fish, so different fish species per 100 meters between all the sites. And Puako is in blue, Old Kona is in green, and Makai is in red. And you can see there Makai is not there because we didn't do Makai in 2009. But there is no significant difference in the number of fish species seen over time in any one of these sites. And that's what this is showing you. And then density is just the absolute total number of fish that we counted in those sites. Again, no data for Makai in 2009. But what this shows you is there's a slight increase in the total number of fish in Puako over time. You can see it's kind of flat, 2009, 10, goes up in 2011, and then up even more in 2012. Old Kona is all over, but it's not significantly different. And then Makai stayed about the same over the 3 years that we've been looking at it. So, in conclusion, Puako had the greatest